In this video, we're going to look at firm cost charts. So we've already covered the labor side of making output. Now we're going to look at the cost associated with producing a good or service. So all of the costs can be broken down into two different categories: fixed cost and variable cost. Fixed costs increase with the amount of production. Variable costs do not. So I'm going to take the numbers from the book and we'll pretend that this is what the numbers for our widget factory are going to be. So the fixed cost, this includes any sort of capital we have. So this would include our building. If we need a really big saw, this would include the saw. The variable numbers would include the saw blade. The more we produce, the more saw blades we're going to be replacing. However, the fixed cost can't increase in the short run. If we have to buy another saw because we're expanding, then we're no longer in the short run. We're moving to the long run, and we're not doing that yet. We're just looking at the short run cost. Okay, so now how do I graph this stuff? So, I should back up and say that one problem that I have is that in this example, the variable costs go up by $2,000 every time that we increase quantity, regardless of if we're increasing by 10 units or if we're increasing by 6 units. It's always a $2,000 increase, and that's not realistic. So our numbers really shouldn't be a linear variable cost curve. I would hope that when you're producing your product at your firm, you don't use a linear cost curve, because that is going to make it so that it's not very realistic, and we want this to be as realistic as possible. However, these are the numbers in the book, so I want to keep them the same so you can reference them when you're working on yours. Okay, so how do we graph this? Well, we can try and graph it freehand, but it'll look the best, and it's required in the class that we use our graphing tool. So I'm going to come over here and open another window in Google Chrome, and here's our graphing tool. Now you'll notice that I already set this up into the output that goes up to 40, well, it's actually supposed to go up to 46, so I'll adjust that a little bit. So that's my x-axis, and I have it set at 45. I'll change that to 50. Hit OK. Now, you'll notice that my graph didn't get all messed up when I did that. A lot of times if you edit the graph and you change the numbers, you'll end up with a graph that's really, really small on this side and really, really long on this side. Okay, and the way that you fix that is you come here to graph settings and you tell the graph that I want it to be, you make sure that that you've clicked this this radial button right here. The default one is this radial button, and you'll see, look at what happens to my graph. It shrinks it down because it's basically trying to keep it in some sort of a scale. But I'm telling it to ignore that scale. I want my graph to look a little bit bigger and a little bit prettier. You can also have it show the grid. I always choose for it not to show the grid, because it just is one more thing to clutter your graph. If you want to set it up to where it shows the grid while you're working on it, and then once you save it, you click to get rid of the grid, then that could definitely save you some time while you're doing it. So to start off with, I'm going to have it not show the grid though. So the first thing that I'm going to graph, the easiest thing that I'm going to graph, is the fixed cost. We know that regardless of however many units we're producing, whether it's 6, 28, or 46, that the fixed cost is going to be $4,000. So I'm going to come over here, grab the line drawing tool, and I'm going to create close enough. I'm going to create a horizontal line at $4,000, and I'm going to call this FC, denoting that that's my fixed cost. Okay. The next thing that I'm going to look at is, I know that this is an increase of $2,000 per increase in output. So I'm just going to plot a couple points and see what this graph should look like. So let me just grab 16. If I'm producing 16 units, that would be somewhere around over here. If I'm producing 16 units, my variable cost is going to be $4,000. So 16 units, all right, somewhere right around there would be 16 units. Okay, 16 units at $4,000, close enough. And then I'll plot one more point saying that at 38 units, so that's 40 units, a little bit shy of 40 units, At 38 units, my variable cost is $8,000. So close enough. 38 units and $8,000 in variable cost. So I know that this is a straight line because of the fact that it's a variable cost increase. But let's say that I don't have a straight line. Let's say that I am using a curved line because that's what it should actually look like. If I'm using the 3-point drawing tool, I can still plot 1 point down here, 1 point right here, and 1 point up here, and I can still have it make a straight line. But if mine increases a little bit more in one area than another, I can definitely adjust it by moving the points afterwards. Okay? So if my cost curves look a little bit more like that, or if my cost curves look something like that, I can manipulate it as I need to. The same thing I could do with the 4-point drawing tool, which is actually the one that you will most likely be using because you'll plot a few more data points, and you'll see that most of the time our cost curves look something like this, where they start increasing rather rapidly, slow down a little bit, and then start increasing again. And most likely yours will look something like that. Now, you don't need to be perfectly precise. If this is the data, then we'll kind of get it close enough to the data. However, the more time you spend playing with this, the easier that this graphing tool is going to be. So let's say that we're happy with that. This is our variable cost curve, and I want to turn my variable cost curve bright green. Okay. And then I'm going to call this, I'm going to grab the text tool, and I'm going to call this my variable cost curve. I'll turn that green too. And then I realize, oh wait, my variable cost at 46 units is actually somewhere closer to $10,000. Well, I can simply grab this and bring it down and say, okay, the variable cost at 46 units is something a little closer to that, and I can manipulate this very easily. Okay, now I want to go back and get rid of these plotted points because the plotted points are very distracting. I'm going to just get rid of them, and I'm happy with my graph now. The last thing that I'll be including is going to be not my stock reports, but the last thing that I'll be including is our total cost curve. The total cost curve is going to have the exact same slope as the variable cost curve. So if the variable cost curve takes a big jump in the middle and then kind of dips down, something like that, then I know without even looking, now this isn't correct for what we're doing, but I know without even looking that my fixed cost curve, or that my total cost curve has to be a mirror of the variable cost curve with the distance between these two lines always being the amount of the fixed cost curve. So if my fixed cost curve is $4,000 between $0 and $4,000, that's got to be the distance between these two. Okay, so let's have it go back and look. Oops, don't need a text tool. Let's have it go back and look a little bit more like the graph that we're working on and the data that we're working on. So I need to reposition this at 16 units, okay, and then right there, okay. And now the variable cost, the fixed cost is starting at $4,000. That means our total cost absolutely has to start at $4,000. And then the distance between these graphs always is going to be the exact same of $4,000. Okay, so I don't even need to plot data for this last curve. I know that it's going to mirror the variable cost, since it's going to be the variable cost plus the fixed cost. I'm going to turn that red. There we go. This is probably the easiest set of curves that we'll be working on. After this, we'll look at our average cost, our average fixed cost, our average variable cost, our average total cost, and then we'll look at our marginal cost. But this is, by far the easiest the easiest ones to work on. I'm going to go ahead and reset this, and I'm going to say that what I'm doing right now does not pertain to this data over here. So we're going to ignore this data. But this is a very typical firm cost curve, and I just want you guys to see another one being produced. So let's say that this firm has a fixed cost of, let's say, $10,000. $10,000 is their fixed cost, okay? And if you haven't already noticed that whenever I'm using the text drawing tool, up in this corner, it tells me what the plotted points would be. So I know that I'm at 50,000 units. I'm a little bit high over there of 10, and you really don't need to be this precise. But if you want to be this precise, then by all means, you can spend extra time and get super precise. Okay, so if any firm ever had a fixed cost curve that was set at 10,000 and they had a total cost curve that went from 10,000 up to, let's say, 16,000, because that's where mine drops off, and this is our total cost, you would be able to go back and figure out what the variable cost would be by subtracting at any point from the total cost the fixed cost. So for example, let's say that we wanted to find out at 40,000 units, if the total cost we see is, let's roughly estimate this to 15. It looks like it's 14.9. Let's say that if it's 15 right there for our total cost, we know that the fixed cost portion of our total cost is 10,000. That means that our variable cost would have to be $5,000. Okay, so I want you guys to make sure that you can work forward and backwards. And in this example, since this is a straight line, I only need to plot that one point, and I could come up with what our variable cost is, because our variable costs always start down here at the origin. So it's got to always be $0 at 0 units of output. And then I pass through that line, and I know that this has got to be my variable cost curve. And we'll see if I'm correct. Then every point, the distance between this point and this point would have to have the same vertical rise, and it does, of $10,000. Okay, so that distance between this curve and this curve is the exact same distance from the fixed cost, from the fixed cost to the floor. So basically, all three of those lines should be the exact same. These two, the two red ones, being the distance between, I'll turn this one green, the distance between total cost and variable cost, and the green line being the distance between fixed cost and the origin, or $0. Okay, if this video was confusing, know that there's a lot going on, and it might take you a couple times to watch this video while practicing on your own graph. Come up with your firm, figure out how many dollars it's going to be for fixed cost, figure out your variable cost schedule, start plotting the points, and then you'll see that the distance between these curves always have to be the amount of your fixed cost. Okay, in the next video, we'll look at the average fixed cost, average variable cost, average total cost, and then also the marginal cost.